On August 26, 2020, American satellite imagery company Capella Space announced the launch of its first publicly available satellite, Sequoia, later renamed to Capella 2, and few people batted an eye. Next, in mid-December of 2020, Capella Space published a blog post celebrating its new status as the provider of the highest resolution commercial SAR imaging in the world. SAR imaging will be explained soon. For now, just replace that jargon with satellite images of unprecedented quality if you so desire. We just wanted to provide an accurate opening sentence because, unfortunately, Capella Space's groundbreaking accomplishments in SAR have been twisted into inaccurate headlines by a fair number of news sites. The seemingly innocuous blog post should really have been only interesting to niche industries, like those who need to monitor infrastructure, assess agriculture, or respond swiftly to disasters. However, the story was picked up by the media, and this time, people are definitely batting eyes. There have been multiple claims along the lines of spy satellite can see inside your apartment. Some call it creepy. Others question if it's the end of privacy. While 21st century concerns about privacy are certainly reasonable, in this case, the headlines are literally flouting the laws of physics in order to stir up their audience. SAR cannot see through walls. But what is SAR? And if it's so innocent, why did all the confusion happen in the first place? The first question will help answer the second. Synthetic aperture radar. SAR stands for synthetic aperture radar, a method of generating an image using microwaves. The radar system sends energy in the form of microwaves towards the surface of interest. To generate the image, the system observes the strength of the energy that's reflected back to it and how long it took this energy to be reflected back. Darker areas of images reflected less energy, while brighter areas reflected more energy. For perspective, here's something more familiar: optical images. Optical images are made using not micro, but light waves, which have a higher frequency. To explain things briefly, the light waves are reflected, refracted, or diffracted by a lens or mirror. This is how everyday photos are produced, whether you're using a real camera or the one on your phone. In fact, this is an extreme oversimplification of how you see. Light passes through the lens of your eye. So when a camera takes an optical image, the resulting photo should be what your real eyes see. Both are using light waves to create the image. Meanwhile, since SAR uses lower frequency microwaves, things are a little different. What your eyes see is not necessarily what you'll get from a SAR image. Since SAR is not dependent on light, images look the same whether taken during the day or night. Additionally, light waves cannot penetrate through as many materials as microwaves can. Wave penetration. As you might expect, the microwave's ability to penetrate through more material comes in handy for imaging. The radar system of SAR emits waves that can see through cloud covers, humidity, smoke, extreme weather, and other atmospheric conditions. A big part of why SAR satellites are so advantageous, especially for first responders to disasters. Imagine how useful SAR images would be, for example, during wildfires. By the time these waves have traveled through the atmosphere and gotten closer to Earth's surface, however, they've lost a lot of energy and spread into a larger beam. They cannot penetrate through buildings. They will be reflected, resulting in bright areas on the image. However, in practice, not all buildings on SAR images are bright, opaque shapes. Some take on a ghostly appearance, the fuzzy kind of white you see in X-rays. One could almost call them transparent, or more accurately, translucent. But the news headlines clearly weren't going for accuracy. One of the images produced by Capella Space's high-tech satellite, a detailed view of skyscrapers in Tokyo, shows such buildings. It was this image that led to the panic-inducing headlines. If the SAR microwaves are reflected by the buildings, then why do they look like ghosts? The layover effect. Capella Space themselves provided a blog post with a clear explanation of their technology. You can practically feel the exasperation in the title of that blog post. No, SAR can't see through buildings. They describe the layover effect, a consequence of SAR during which tall objects appear to lay over onto others. Essentially, what happened to results in the Tokyo skyscraper photo was this. The satellite released microwaves as usual. These microwaves bounced off multiple skyscrapers, and when the satellite received all these different data at once, the skyscrapers were overlaid on top of each other. This created the translucent effect. Capella Space's blog post is worth checking out. It's written by the people who created this technological feat after all, and it has some helpful diagrams. In short though, the see-through buildings are a natural phenomenon that results from SAR. And if you look at the image itself, you can easily see that you won't glean any useful information about the contents of the skyscrapers. No one's going to be looking inside your apartment with a satellite anytime soon. That sort of technology simply doesn't exist. Privacy protection. Knowing that the Earth is under the Capella 2 satellite surveillance might still concern you. Not to worry. There are plenty of other precautions in place to protect your privacy. As Capella Space notes in their blog post denouncing the see-through buildings myth, they are subject to many rules and regulations in the United States. They are compliant with regulations put in place by the International Traffic in Arms Regulations, ITAR, the National Oceanic and Atmospheric Administration, NOAA, the Federal Communications Commission, FCC, the U.S. Commerce Department, and more. The Commerce Department limits the resolution of images provided by commercial SAR technology to 50 centimeters by 50 centimeters. This resolution is powerful enough for images to display ships, aircraft, and other large vehicles, but is not powerful enough to reveal personally identifiable information like license plates. It can't see people either. Finally, even though Capella Space is making this technology commercially available, the company vets all of its customers and partners. Their images are to be used for ethical purposes only. Conclusion. As far as privacy-breaching technology goes, if you want to worry, you'd be better off worrying about something closer to home. Net neutrality, perhaps. Little Capella 2, orbiting innocently in space is, as you've seen, no cause for concern. In fact, Capella Space hopes that their technology will do good, and it certainly has a lot of potential for that. Emergency resources, for example, can be more effectively allocated if SAR images are used to see which areas are flooded worst. Soil moisture and vegetation damage can be tracked to help in the agricultural fields or with conservation efforts. It's healthy to have a bit of skepticism. There's nothing wrong with wanting to investigate when flashy news headlines claim that new satellite technology can see through walls. But now, with the facts all laid out, it's clear that those headlines were all flash, no substance. We haven't yet reached the point of developing cameras powerful enough to see through walls, and when we do, chances are it'll be on Earth first, not a satellite that's 525 miles away.